So we've covered the second type of logarithmic axis plotting and graphing. What I'm going to do in this video, I'm going to show you some questions of this format. I want you to pause the video, have a go at the questions, come back and then check your answer against this set of working. So here are the questions for you. Two variables are connected by the formula y equals kx to the n. When log y is plotted against log x, the graph passes through 0, 3 and 8, 7. Find the values of k and n. And then the second one, I want you to find a formula of the form g equals kp to the power of n for this plot here. So I've got log to the base 10 of g against log to the base 10 of p going through these 2 points. So pause the video and have a go at those two questions. So our first question, two variables connected by that formula. When log y is plotted against log x, the graph passes through 0, 3 and 8, 7. Find the values of k and n. So in order to do this, we have to think like we did before. We know that y equals kx to the n. We know that log y plotted against log x is equal to each other, giving us a straight line. So what we can then say is fine, so log y equals log of the other side, so log of kx to the n. And again, similarly to the other version of logarithmic axis plotting, we can take this and strip it apart using our rules of logarithms. We know that's going to be equal to log k plus log of x to the n. Bring the n down as a power. That's going to equal n times log of x plus log k. And that's going to be log of y. Now, that again is similarly informed to a straight line. So our y equals mx plus c, our formula for a straight line. From this, we know log y is equal to the y, log x is equal to the x, log k is equal to the c, and the value of n that we get here, that's equal to a gradient. So to get log k, and to get k ultimately, we look at the y-intercept, and to get the n, we just look at the gradient. So y-intercept, well, we can read that from the point there. We know y-intercept log k equals 3, so we then know that k equals, well, bring the base up, there's no base written here, so let's imagine we take log 10, 10 to the power of 3, k equals 1000. What we can then do is look at the same parts here. Well, we know that n equals m, so we know that n is equal to the gradient of the line, so in this case, y2 minus y1 over x2 minus x1 using our points. So y2 minus y1, 7 minus 3, x2 minus x1, 8 minus 0. 7 minus 8 is 4, 4 over 8 gives me a half. So what I'm able to then say is I know that that's equal to n, so n in this case is a half. So there you go, I've got my two values. Now, if it wanted a formula, I could substitute them back into this and get a formula. However, it just wanted the values of k and n, so I can just leave it like that. However, this one wants a formula. So it wants us to find a formula of the form g equals kp to the n, and this is the set of axes that we've got. Now we know that g equals kp to the n, and we know it's log to the base 10 of g and log to the base 10 of p there. So let's take log to the base 10 of both sides. So log to the base 10 of g equals log to the base 10 of kp to the power of n. Again, split it up similarly. Log to the base 10 of k plus log to the base 10 of p to the power of n. That's the same as n times log to the base 10 of p plus log to the base 10 of k. Now, the two variables related to each other from the axes are the g and the p. So we know then that if we looked at our y equals mx plus c, the log to the base 10 of p is equal to the x in that formula. Log to the base 10 of k is the c, and again, the n value here is equal to our gradient. So we know now how to calculate these two values. We can just look. Now our y-intercept comes in here. So we know log to the base 10 of k equals a half, or 0.5. So k is equal to 10 to the power of a half. So we get our value of k from that. To get the n in the gradient, we use the gradient formula. So we know that m equals y2 minus y1 over x2 minus x1. So it's 2.3 take away 0.5 over 1.2 take away 0. 2.3 take away 0.5, that's 1.8 over 1.2. Simplify these, so that gives you 18 over 12, which is 9 over 6, which gives you 3 over 2. So my m is 3 over 2, which means my n is 3 over 2. What I can then do is substitute these into the formula and get an answer here. We know 10 to the half is the root of 10, so what I can then say is fine, so g equals root 10 p to the power 3 over 2. I've got my formula relating g and p using this set of principles and this set of conditions. This is how you approach questions like this. Whether it's the first form or the second form, we think the exact same way. We have to take logarithms of both sides, rearrange it to get it in a form similar to y equals mx plus c, and then break it down from that and use the information we're given to solve it and get what we're after.